As we look at this concept, I'm going to look at the concept of
Teacher, teacher, I beg you ring the bell. Teach your children, teach them how to spell.
welcome again, guys, to another of my YouTube video. And in so doing, my focus will be, it's a continuation on sets. In my previous lesson, we would have defined a set, indicating that a set is a collection of items or object that is well defined. Now I'm moving further. I will be looking at some concept that is being used. As you can see on the board, this symbol here looking like a U, which stands and indicate that this is our universal set. And the universal set here is prime numbers less than 15. So what we need to do first is to identify what these members are, or what these elements are, based on the conditions and the criteria given, as it's indicated, prime numbers less than 15. Now we may want to ask ourselves the questions as well, what are prime numbers? So prime numbers are numbers that can only be divided by itself and 1. And the first prime number, bear in mind, is the number 2. So always bear in mind that 2 is the very first prime number. Now what we need to do is to list all these elements that consist. So I'll be going ahead and listing what the universal set should be looking like. So our universal set, it consists of prime numbers that are less than 15. In this case, it will be 2, 3, and remember guys, we separate each element using a comma. 5, 7. Is 9 a prime number? No, because 9 can be divided by 3 as well. So it is not a prime number. 11, 13. It says those that are less than 15. So in listing the universal set, we can see that all elements within the universal set there is 2, 3, 5, 7, and 11. Those are the elements of that made up that universal set. Now I'm going to be listing a few sets that we are going to use to work, and what we refer to as subsets. In other words, they are part of the universal set. So one of my sets is going to be called A, and the elements in A are 2, 3, 5, 7. Remember, these are all subsets. These are elements that are taken from our universal set. Now the set I'm going to use is set B, open bracket. The elements are 2, 3, 7, 11, and 13. And my other set is set C, which is consists of 2 and 3. And D is also a subset. And the elements in D, or the element, our member, is the digit 3. Now, so bear in mind, guys, that as you can see, a set is denoted by a capital letter. All elements are separated using a comma, and also it's represented using curly brackets. Now, again, we said that the members are, as we look at this concept, I'm going to look at the concept of elements. If I right here, you could say the 2 is an element of set A. So note that this symbol represents element. Likewise, I could also say that 3 is an element of set B. In other words, 2 is in set A, 3 is also in set B. But what if it is not an element? For example here, 11 is not an element of set C. So note what I've done here. The symbol, this is the symbol representing not an element. This is the symbol indicating that it is an element. So as you can see from here that 11 is not a member of set C, or in other words, 11 is not a member of set C. I'm just reinforcing each concept using the information we have. Let's look now at number of elements. And when we speak of the number of elements, we are simply counting each element within the given set. So if I add a number of elements n in set A, what would be my response? The number of elements in set A is simply 1, 2, 3, 4. There are 4 elements in set A. Number of elements in set B, again guys, we are counting each element. 1, 2, 3, 4, 5. So we know that there are 5 elements in set B. If I go on to look at set C, number of elements in C would be 2. A number of elements in D would be equal to 1. So again, for a number of elements, we are counting each element within the given set. Now, want to look at, earlier we speak of subset. I'm erasing below because I'm using this information as we go along. Subset. In other words, we are saying that a subset is a part of a larger set. Some person may say a subset is a part of the universal set. Now, if I look at C, I can see that the elements in C are also in B, and the same elements can be found also in set A. So it would be fair for me to say that set C is an element of set B. Sorry, is a subset of set B. And note the symbol is turned this way, just like a U looking in that direction. So it is fair for me to say that set C consists of, is a subset or part of set B. I could also indicate here that set A is a subset of B likewise. So look at the symbols. In other words, so what we are saying here, guys, that the elements in C can also be found in B. And these elements, as we can see, 2 and 3 in C, 2 and 3 likewise in B. Set A is a subset of B, the part of. So in other words, the elements that I see here in A that are also in B are also 2 and 3. Now I'm going to be looking at what we refer to as the intersection. So intersection, we are simply looking at elements that are common to more than one set. So I'm looking at elements that are common to both So for this intersection, we are looking at elements that are common to both sets. And look guys, it is written, so if I look at set A and set B, A intersecting B, so I'm looking for what are the elements that are common to A as well as common to B. And in this case, we can clearly see the elements are 2, 3, and 7. So from what we are seeing here, that the elements common to set A and B are 2, 3, and 7. So in other words, these elements intersect. Again, we will also look at these elements when I represent the same information on a Venn diagram. Let me try another one here. A intersect D. Are there any elements that are common to A and common to D? Yes. The element in this case is one single element, which is 3. What about C intersecting B? C intersect B. Are there any elements in C intersecting B? Yes, we can see that 2 and 3. So the elements are 2 and 3. So remember guys, again, these elements are separated by brackets, by commas, and they are also being placed in curly brackets. Another concept I want to look at. Remember, you can always pause the video and go back. All elements that are in both sets, that's what we are looking for when we speak of union. And in this case, if I have here A union B, right, and I hope that you are paying keen attention to the symbol. So A union B, we are looking at all the elements that are in A as well as the elements are in B. And remember also that we don't repeat an element or member. So let us list the element in A, 2, 3, 5, 7. Are there any elements that we missed? So we have 2, 3, 5, 7. We already listed 2, 3, and 7. 11 from B and 13. So the union of A union B will be 2, 3, 5, 7, 11, and 13. Those are the elements that are in union in set A as well as set B. So you combine all elements or members to form the union. Now what if you were asked the number of elements in A union B? So if you were asked a question, how many elements are the number of elements in A union B. What we need to do in this case, guys, is to count the members of element. 1, 2, 3, 4, 5, 6. So it would be 6 elements in A union B. Let us take another one. I'm going to take C union B. So first I'll just go ahead and list the elements in C. 2 and 3. Are there any elements in B that I have not yet listed? That would be 7, 11, and 13. So C union B, these are the elements. If you were asked number of elements in C union B, we are counting the elements 1, 2, 3, 4, 5. The outcome would be 5. Now guys, so we would have identified here what is meant by universal set, which is a given set. I've gone ahead and I've listed all the elements, given that it's in worded forms. So I've listed the elements using raster or tabular form, and the elements are, as you can see on the board. Then I've actually created some subsets from the universal set. I've set A, B, C, and D. Then I've looked at what is meant by element, simply the members of a set. We look at the symbol that means a member of, not a member of. I've also gone ahead and we looked at the number of elements in each set, where it said in that case you would count the elements. We have looked at the subset, which is a part of a given set or the universal set. I've looked at the intersection, where we said the intersection are the elements that are common to both sets. And I've looked at union, where we speak of all the elements that are in both sets. So it's a combination of the members within the set. If you like my video, if it has interest to you, like, share, most importantly, subscribe until we meet again in the next lesson. Bye.